Alright, we are going to talk about rational numbers. So first off, I want to talk about the different types of rational numbers. So first we're going to look at whole numbers. So whole numbers are the positive numbers that do not have fractions or decimals. So it starts at 0 and would be 1, 2, 3, 4, and so on. Integers are positive and negative counting numbers. So there's no fractions or decimals in that either, but it does go into the negative. So you've got -2, -1, 0, 1, 2, and it goes on and on in both directions. So the basic idea of rational numbers is any number that can be written as a fraction. So that includes terminating and repeating decimals, because those can be written as fractions. And then the opposite of rational numbers are irrational numbers, which cannot be written as a fraction. So they can be decimals that don't terminate or decimals that do not repeat. So I want to look at it thinking about how we would compare the numbers on a chart. So basically a number is either going to be a rational number or an irrational number. So it's one or the other there. But then within rational numbers, their numbers can be more specific. So the next most specific type of rational number would be integers. And then even more specific than that would be whole numbers. So rational numbers, for example, would be 5.3 repeating, or -8.24. Integers could be -7, 50. Whole numbers could be something like 10. I've put charts of how you can convert between rational numbers, fractions to decimals, decimals to fractions, decimals to percents, fractions to percents, all of that you can review if needed. And then we're going to use that to be able to convert and compare and order the rational numbers. So first we're just going to look at comparing. We're going to fill each circle with either less than, greater than, or equal to sign to make the statement true. So looking at this first one, we've got -3/8 compared to -5/16. So since they're both in fraction form, I could turn them into decimals if I want to, or I'm going to just compare them as fractions with common denominators. So 8 and 16, their least common denominator is 16. So I'm going to rewrite these with that denominator of 16. Well, 5/16 is already in 16ths. The 3/8, well, 8 times 2 is 16, so 3 times 2 is 6. So we're comparing just the numerators here, -6 and -5. Well, normally 6 would be bigger than 5, but we're talking about negative, so it works in the opposite direction, which means that -6/15 is less than -5/16. For number 2, we've got -12 and 44/100ths compared to -12 and 9/20ths. So we've got a decimal and we've got a fraction. So I can compare these by either making them both decimals or by making them both fractions. I think it's easiest to turn things into decimals, so I am going to turn 9/20ths into a decimal. So on this side here, I'm just going to divide 9 by 20. Well, 20 can't go into 9, so I add a decimal, goes in 0 times, add a decimal here, add a 0. 20 goes into 94 times. 20 times 4 is 80. Now I can subtract, I get 10. I still have a remainder, I'm going to add a 0, bring that down. 20 goes into 100 5 times, which means my -12.44 stays the same. The -12 and 9/20ths is the same thing as -12.45 or 45/100ths. So since the whole number parts are the same, all I need to look at is the decimals. So I've got -44 and -45. Normally 44 would be less than 45, but since it's negatives, it works in the opposite way. So -44 is actually greater than -45. And then the last one here, we've got -3 and 5/8 compared to -3.625. So again, I've got a fraction and a decimal. I want to make them the same, either all decimals or all fractions. I think it's easier to convert them all to decimals. So I'm going to divide 5 by 8. So 8 goes into 5 0 times. So I add a decimal, I add a 0. 8 goes into 50 6 times, which is 48. When I subtract, I get 2. So I add a 0. 8 goes into 20 2 times, which gives you 16. Subtract, I get 4. Add another 0. 8 goes into 40 5 times. Now I got my remainder of 0. So over here I've got negative 3.625. On the right side I've got negative 3.625. They are exactly the same, so they are equal to. So that's just comparing. Now we're going to look at ordering them from least to greatest. So we've got a few more numbers here that we got to compare. Again, majority of the times I think it's going to be easiest to convert them to decimals. So here I've got negative 3.3, negative 370%, negative 7/4, and negative 3.3 repeating. So I'm going to rewrite these all as decimals. We've got negative 3.3, which is already a decimal. For the percent, I ignore the percent, add a decimal point, move it twice to the right to turn it into a decimal. So we've got negative 3.70. 7/4. Either you can look at that as a improper fraction turned into a mixed number, negative 1 and 3/4, and maybe you realize that 3/4 is equivalent to 0.75, or I can divide 7 by 4. 4 goes into 7 once. You get a remainder of 3, so I add a decimal and a 0. 4 goes into 37 times, which is 28. Subtract, we get 2, so I add a 0. 4 goes into 25 times. So we still will get that same answer of negative 1.75. And then the negative 3.3 with the bar means that it's repeating. So it's negative 3.33, however many I want to add. Well, I've got one decimal value, two decimal values, two decimal values, two decimal values. So I'm going to change this first one by adding a 0 so they all have the same number of decimal values. So we got to order them from least to greatest. Well, remember, a bigger negative is actually a smaller number. If I look at these three have the same whole number value. This one's different. It's negative 1, which I know is going to be greater than negative 3. So I already know that's my greatest. So that's going to be the fourth one. Now I'm just looking at these. I got 30, 70, and 33. Remember, a bigger negative is actually a smaller number. So 70 is the biggest one there, which means it's our smallest number. So that's 1. Then we've got 30 and 33. Again, bigger negative is a smaller number, so 33 is bigger than 30, which means that is the smaller one, and then would become 3.3. So when I list them in order, I'm going to put them back in the original form. So our first one was the negative 370%. The second one was negative 3.3 repeating. The third one was negative 3.3. And the fourth one was negative 7/4. And then last problem here, we've got negative 2.43, negative 2 and 7/10, negative 13/5, negative 2.07, and negative 2.5. So 3 out of these 5 are already decimals. I'm going to convert the two fractions into decimals. 7/10, hopefully we can realize that that converts to 0.7. So this is going to be negative 2.7. I'm going to rewrite the others. And then negative 13/5. Well, I could either convert this to mixed numbers. It goes in twice with 3 left over, and maybe you know the conversion of 3/5, or I can divide. 13 divided by 5. 5 doesn't go into 1, but it goes into 13 twice to give you 3. Add a decimal, add a 0. 5 goes into 36 times. So negative 13/5 is negative 2.6. Then we've got negative 2.07 and negative 2.5. So again, I want to make sure they all have the same number of digits after the decimal point. So we've got 2, we've got 1 here, so I'm going to add a 0. We've got 1 here, I'm going to add a 0. We've got 2, I've got 1, so I'm going to add a 0. So a bigger negative is a smaller number. So we've got 43, 70, 60, 7, and 50. So our biggest negative here, our smallest one, is the 70. After 70 would be 60. After 60 would be 50. After 50 would be 43. And after 43 would be 7. So when I'm putting these in order, put them in the original form. We've got negative 2 and 7 tenths. Then we've got negative 13 fifths. Then negative 2.43. Then negative 2.5. Then negative 2.43. And then the last one is negative 2.07.